Hello Year 8. This short video is aiming to talk you through the structure of the atom and how to represent that using a Bohr diagram. So the first slide here that you can see is a representation of an atom with two positive subatomic particles in the middle, represented by these two red circles and the plus inside, and these two represent protons. We've also got two other subatomic particles in what we call the nucleus. So the nucleus is the centre of the atom, and that's where the mass comes from. The rest of the atom is largely empty space with these tiny negatively charged electrons whizzing around the outside, but the mass comes from here. So this atom has two protons, and it has two of these circles, the green circles, which represent something called neutrons. The two protons are the thing that defines the atom, gives the atom its properties, its identity, and we can see that with two protons we have an atomic number of 2. That tells me that this atom is helium. Okay, so if you look at your periodic table and you look along the lines, you'll see that they go up sequentially. Now in one corner you'll find hydrogen with an atomic number of 1, and in the other corner you'll find helium with an atomic number of 2. You'll also see underneath the He for helium, you'll find that it has a mass number of 4. That means that there are 4 subatomic particles in the centre. And I can work out that there are 2 neutrons just by looking at that symbol. And here are my 4 subatomic particles that make up the mass number. So this is where the mass of an atom comes from. The rest is empty space, and much more empty space than this diagram is able to show you. And the electrons are absolutely tiny. They don't contribute to the mass of an atom. They do have a negative electric charge, and they whiz around the nucleus in what we call electron shells. So we'll have a little look at how we organise our electrons around an atom. But there are 3 subatomic particles that you need to consider, and they're the ones that you can see in this diagram, and you will need to represent in your own card that I've given you. So let me just have a look at an example. So this is something that I'd like you to do. Let's move this down so you can see the words. I would like you to choose an atom and then represent the atom using the chemical symbol as you find on your periodic table. Now please stick to the top 20 atoms ideally, to keep things simple and to ensure that you can actually draw a Bohr diagram and represent all of the subatomic particles well on that. So sodium here, if you draw the chemical symbol, and here we've got Na, but always remember that the uppercase, the first letter is uppercase, and the second letter, if there is one, is lowercase. Here you can see hydrogen doesn't have a second letter, so it's just an uppercase H here. Whereas helium, the one we looked at earlier, is an uppercase H and a lowercase e. So we've got the symbol, the word for that element or that atom, and then we've got in red here the atomic number, and down here the atomic mass number. Now in year 8 I don't mind if you round that to 23. That will help you at the moment, and when we start to talk about isotopes and different versions of atoms next year, you'll start to understand why they're actually decimals. So using sodium as an example, we're going to look at how to draw a Bohr model. So you'll use your own example, ideally not helium or sodium, something a little bit different. And we'll start with this atomic number at the top, which tells you that there are 11 protons in a sodium atom. Okay, so I would like you to represent the protons as a circle with a plus in it, showing that you remember that they are positively charged subatomic particles. Underneath, the bigger number is the mass number. Now that's made up of the whole mass of the atom, which is the protons plus the neutrons. So you need to work out how many neutrons there are. So you'll do this, 23 minus the 11, which gives us 12. So this atom has 12 neutrons and 11 protons in the centre, in the nucleus. And here we've represented the neutrons as a green circle. This is just a scientific model to give us a general way to communicate our understanding of atomic structure. It doesn't actually represent what's really inside. They're not little round red balls and green balls in the center of the nucleus. Okay. You can see here what I have started to do is add 11 protons and 12 neutrons in here, adding up to the 23, the mass number of 23 for this particular sodium atom. And then how do we work out how many electrons there are in a neutral? So all of the atoms in the periodic table that you have in your book are neutral. They don't have a positive charge overall. They don't have a negative charge. Those charges are balanced. So to balance out those 11 positive charges from the protons, we need 11 negative electrons. And we're going to arrange these in a particular way. I'm just going to move the screen down. Hope that's not annoying. We're going to arrange them in what we call electron shells or energy levels, and you'll learn a little bit more about that next year. But here I've drawn on the shells that we need to represent. And there's one little electron whizzing around the nucleus there, but we need more than one. So the first energy level has only got enough space in it for 2 electrons. So think of it as parking spaces. There are only 2 right next to the shopping centre, and then all the other electrons need to go a little bit further away. So only 2 electrons can ever fit in the first circle, or the first energy level, the first shell, and then the next 8 can go in the next energy level, or the next electron shell. And then we got up to 10, so I'm going to squeeze, again you can't see, move the screen. I've put the 11th electron, so we have 11 protons, so we must need 11 electrons. I can only fit 10 in if I fill the first with 2, the second with 8, so my 11th has gone in the 3rd electron shell there. And what we can do is write that electron configuration, or how the electrons are organised in the sodium atom, like this. We can write 2, 8, 1, showing that in the first shell there are 2, in the second shell there are 8, and in the third shell there is 1. So, looks like my battery's going. So your mission now is to choose some atoms and represent those exactly as I have, using what we call the Bohr model. And you'll learn a little bit more about Niels Bohr and how he tested this model and discovered the structure of the atom that we are representing in this diagram. But that probably will have to wait until year 9 as well. Okay, well done.